Algebra 1, this is chapter 5.5. We're going to solving inequalities that have absolute values in them. Yes, they are a little bit daunting, I think, at first. But I got case 1 and case 2 here, and really what it comes down to are those two sets of rules here, where the first one is you always drop the absolute values. And then second one, you will drop the absolute value in there and then take the opposite value of C and flip the inequality. If you remember those two rules, all of our problems are going to go away. So it doesn't matter how you want to work this out, it does work every time. So as we can see, that if you had an absolute value on some expression being less than or equal to C, this is the first rule. First rule says just get rid of the absolute values. If I do that, I will have x minus a is less than or equal to c. That's exactly what we have here, just no absolute values. The other one says drop the absolute values again, so x minus a. Take the opposite of c, so opposite, whatever c is, take the opposite, and flip the inequality. So now instead of being less than, it's greater than or equal to. Okay? We also don't worry about this line right here. I think we're just going to skip that. We're going to keep them separate because if you remember from the last lesson on the compounds that eventually you could write it as one single inequality. Case 2, what happens if it's a greater than or equal to? Again, drop the absolute values, x minus a. Keep it the same, it's greater than or equal to c. This time you're going to put an or because they're going to go away from each other. X minus a, drop the absolute inequality, absolute value, again. Make it the opposite of c, flip the inequality. So in both cases, I drop the absolute values is half of it. The other half is drop the absolute value, take the opposite of c, flip the inequality. You do that, you're not going to have a problem. Solve them individually. So I've got 3 examples here. I'm not sure if we're going to do all 3, but these ones are of less than symbols. So less than or equal to. Remember, case 1, case 2. Case 1, drop the absolute values. We don't want them. Remember, absolute values make things positive. Does not make things opposite. Positive only. So the absolute value of 5 is 5. The absolute value of negative 10 is 10. Case 1, drop the absolute values. N minus 8 is less than or equal to 2. These are AND problems. And then you have to do case 2. Drop the absolute values again. Make it the opposite of the value of C. And then flip the inequality to say greater than or equal to. You now have a problem just like the last lesson. Solve it individually. The coolest thing about a lot of these problems is that since the beginning parts are the exact same, it's the exact same step. So I'm going to add 8 to both sides here. So n is less than or equal to 2. And got to add 8 again. And so n is greater than or equal to negative 2. And now I just have to graph these. And remember, this is an and, so it has to go together. Negative 2 is on the left, but 2 is on the right. And here's the cool thing. On these particular problems with absolute values, the symbols will be exactly the same. So both are going to be closed because they're both equal to's. In this particular problem, 0 is in the middle, so that would be great. Is 0 greater than or equal to negative 2? Absolutely. I would shade up. Going here, is 0 less than or equal to 2? Absolutely. I'm going to shade downward. And because this is an and, it has to be where they overlap. And so the answer is directly in the middle. And like I said, you could use a single compound inequality and represent the answer as negative 2 is less than or equal to n, which is less than or equal to 2. But the graph looks like this. Let's skip example B and let's move to, no, let's do example B because it has a 2 in front of C. We'll at least set it up. So remember, drop absolute values. Great. And, because this is a less than problem, drop the absolute values again, switch the sign, and make it opposite. And now you just have to solve this. Again, I'm going to add 5 to get the c's by himself, so 2c is less than 10. So as I do this, I'm going to add 5 over here. So 2c is greater than 0. Well, that's not too bad. I can divide everything by 2. C is less than 5. And divide by 2. 0 divided by 2 is still 0. So if I make, not that kind of line, number line here, 0 is over here, 5 is over here. They are both open dots. It says C has to be greater than 0. Well, I can't use 0 for the 0 side, but I still can use 0 here. Is 0 less than 5? Yes. So I'm going to shade towards 0. When I have C here on this one, I can't use 0. So I'll use 5. How about I use 5? Use the other point. Is 5 greater than 0? And you're like, yeah. So therefore, I shade towards the middle. Okay? So that's how you're going to do those problems. That is for less than problems. In this one, we're going to deal with the greater than problems. We'll do just the first one because it's the more complicated of the two. Same rules apply. I don't care which way the inequality symbol is, if it's greater than or if it's a less than, drop the absolute values. That's half. Now this one's an or. Now if you guys are I don't know if it's going to be an and or if it's going to be an or, the coolest thing is you don't necessarily have to worry about it till you get to the end. If they go towards each other, that's an and. If they go away from each other, that's an or. And then it's 2k, drop the absolute values again, and then flip the inequality and make it negative. So therefore, there's your two inequalities. Solve them. Subtract 1, 2k is greater than 6. Or subtract 1, 2k is less than negative 8. Divide by 2's all the way across. K is greater than 3, or k is less than negative 4. So when I go to my number line, these ones all seem to be switched around. And it's going to happen. Both are open. Okay, where's k greater than 3? Maybe we don't have to necessarily check points. 0 is in the middle. 0 would not work, so I'm going to shade outward or to the right. Is 0 less than negative 4? Absolutely not, so I'm going to shade this way, and that is why it's an or problem. They go away from each other. Your homework, I would like you guys to do these 6 problems. As you can see, there are 3 less thans and 3 greater than problems. Make sure you use your 2 cases. Drop the absolute values, keep it the same. Drop the absolute values, flip the sign, make it opposite. Have a great day.